Hi, guys. I miss you so much. I'm going to be talking with you today about the balancing equations chapter. I had you yesterday look at your notes that were sent home with you in your packet and try to make sense of what you could figure out and what things were still unsure that you were questioning, and send those to me. And I really appreciated that feedback. That lets me kind of know um, if there are particular areas that I need to focus on to help you out or not. And then were a few questions that were sent in, so we'll make sure and get those addressed during this time together. And with that, I'm going to go ahead and get started with how to balance an equation, and we'll start from the beginning to the end. Okay, so the first thing I want to do is just do a real quick review of how do you know how many atoms are in any particular compound. So I'm going to do a few examples. So let me change this just a tad so you can see the board all the way. Okay, because the board's important, not me. All right, so we're going to do CCl4. Okay, now in CCl4, remember that the subscript numbers are what tell you how many of those elements are attached to that subscript number. So here we have a carbon. There is no subscript showing, and remember that's an understood 1 when you see no number. So in this case, we would have 1C. Make that a little darker. Okay. And on the chlorine, we would have a total of 4. Okay. Now, if we have another one that is, let's see, Fe. Oh, there's one of your polyatomic ions. Do you remember that one? OH, hydroxide. And that has a coefficient. Okay. And so we see here that we have actually 3 different elements in this compound. We have an iron, we have oxygen, and we have hydrogen. Now, how many of each one do we have? With iron, no subscript here, so that means there's just 1. The OH is in parentheses, so remember anything in parentheses is affected by the subscript. So the subscript being 3, that's going to distribute to both elements, and that means we'll have 3 OHs, or excuse me, 3 O's and 3 OHs. That's kind of a terrible looking 3. Okay. So remember to, if you see parentheses, to distribute the subscript amount to any elements that are in those parentheses. Okay? All right. I'm going to do one more. And this is, we're going to go back to our carbon tetrachloride, CCl4. Okay? But I'm going to make it a little different this time. So I'm going to put a 3 in front of it. Now this is what we call a coefficient, and this is the subscript. Okay? So a coefficient is always found as a number in front of the compound, in front of that formula. And if we look at this, let me get rid of that 4 back on there, normal. That's a 4. Okay. Then we're going to count them again. Now again, we have carbon and we have chlorine. Okay. Now in just the CCl4, we saw that with no subscript, we had 1C. But when there's a coefficient in front of it, that means we have 3 of whatever the C has. So with 1C in this formula, we're going to triple it. So C actually in this case would have 3. And then the chlorine, normally in just that formula, has 4 of them. But again, the coefficient is going to make us do Cl4 3 times. So basically 4 times 3. So we're going to end up with a total of 12 chlorines because of that. So that's how you treat the counting of how many atoms of any elements that are involved when there is a coefficient in front of the formula. Okay? All right. Now, oh my goodness, let me get my eyeballs on, guys. Okay. Now, in the very beginning of the notes, we talk about the law of conservation of matter, and that's what we looked at way in the beginning of the year. Again, that just means that matter can neither be created nor destroyed. It simply changes form. And basically, that just means that whatever atoms you start with, and you do something to them, you're going to have to end up with those same atoms at the end, but it's got to be in the same amounts, because you can't just say poof and it goes away, or poof, I just created something that I needed. It has to be from what we already have existing on Earth at this time. So I'm going to go through and do our first equation together. This is the one that I had in the notes that I had step by step, and so you should recognize it. Plus O2 yields CaO. Okay, I should have started farther over. Okay, now the yields is the breaking point here in the equation to let you know where your reactants are. And here is your product. Okay, now don't worry about the fact that there's 2 on this side of the yield sign and 1 on the other side. That's okay. You'll see that everything balances out. It doesn't matter. You can have one thing on one side of the yield sign. You can have 2 molecules. You can have 3 molecules on one side. But you don't have to have the same amount on each side. As far as I have 2 different things here, and there's a plus sign separating them. But over here, I just have one thing, and there's no plus sign. There's no other compound present or element present. It does not matter. Okay, so just forget about that. Don't worry about that. The plus sign just lets you know, hey, this is separate from this at the moment. Okay. All right. So let's do our counting real quick. And you need to do counting on both sides of the equation, both the reactant amounts and the product amounts, okay? So we're going to go through here, and in this equation, we have calcium, we have oxygen. Make sure it's showing up okay. And we have nothing else. We only have 2 elements that are making this up. So let's do our initial count, okay? On the reactant side, I have 1 calcium. There's no subscript. And funky O. And on the oxygen, I have a subscript of 2, so that lets me know that there are 2 oxygens on that side. Now, I'm going to put a yield sign in between just so I can mentally, really quick, just without even really thinking, understand that I'm talking about how many reactants there are and how many products there are, okay? Now, when I look over here at the product side, I see no subscripts whatsoever, so I know I have 1 calcium and I have 1 oxygen, okay? Now, if both sides for an element match, then that element is balanced. But in order to have a balanced equation, you have to have every element involved totally balanced before and after the reaction has happened. And as we can see here, there is, it's not very dark, you can see that we have calcium is balanced, seems fine, but oxygen is not. So we start out with 2 oxygens, but then when we get done with the reaction, we only have 1 oxygen. That doesn't sound right, because that would just mean that 1 oxygen just poof, it just disappeared from Earth. And that's not the case. We know that. So we have to balance it. That means that you don't have enough of either reactants or products, or maybe both, in order to make a complete reaction happen. So in order to balance, we're going to take a look. Now, my calcium, it seems fine right now. It might change, and you might not end up with having 1 atom of calcium in the end. But for now, we're going to leave it alone. Oxygen is where we want to start here, because it's out of balance. So we have 2 oxygens on the reactants, and there's only 1 oxygen on the product. Okay? So a real quick, easy way to do that is, I'm going to underline here. You don't have to underline, but I'm doing it just because it'll draw more attention here. You're going to put a 2. Okay? Now, when I put a 2, there, that again is going to be distributive, and it's going to apply to both elements, Ca and O. So I'm going to end up with changing, and my calcium here is going to change to 2 of them, and also my oxygen is going to change to 2 of them as well. So when I do that, oxygen turns out to be balanced. Yay! But we messed up calcium. So calcium needs a little fixing. So we're going to go back, and we're going to say, all right, I've got more product than I do reactant. So is there any way that I can change and make the beginning calcium count match? And that happens to be, in this particular case, very easy to do. All you're going to do is put a 2 in front of the Ca, and that will change. Ca is the only element there, so it's going to change that to 2. And now we look at 2 calcium and 2 oxygen. We're totally balanced. All right. Now, the one thing you want to do before you say, oh, I've solved it, I'm done, is you need to look at your coefficient ratio. Okay. Now, the ratio for this particular balanced equation is 2, 1. Remember, if it's not showing a number, it's an understood 1. So there's 1 O2 and 2 CAs. So this would be the coefficient ratio, and for the balanced equation, and you have to check it, because in nature, Mother Nature is very smart, and she only balances things in lowest whole number ratios. So if you look at 2 to 1 to 2, that cannot be reduced any further. So that is a lowest ratio, and that means that we are completely balanced, and that would be our final answer. And when you do these for me in this long distance way of doing things, if I ask you to balance equations and I say, okay, submit your answers to me, this ratio would be all I would require from you for this type of an exercise. So when you say, well, the answer to the balancing of, equation number 10 is 2, 1, and 2. 2 to 1 to 2. Okay? All right. Now, get rid of that one. Next, let's do this one. Start way over here. Okay, so I have Ca. There's our hydroxide coming up again. OH2 plus HCl yields. I'm running out of room now. Let me redo it. I'm used to a bigger board. Okay, so let's do over here. Ca, there's our hydroxide, plus, need to have a little room in front of it because we might need a coefficient. And then I had HCl. Again, I'm leaving a little bit of room here so that I can have room to put in a coefficient as I work through it. The yield sign. And then we have, again, a little room. CaCl2 and water. What's water's formula? Leave a little room. And then H2O. Okay, so that's the unbalanced equation. At least that's what I think. I think it's unbalanced. That's why we always do an initial count. Because sometimes you'll have a balanced equation that doesn't have any coefficients showing. I'll show you one of those in a little bit. So let's do our initial count here. So I have calcium. I have oxygen. I have hydrogen. And there's another hydrogen and, oh, chlorine. All right. Chlorine. All right. So, and you can double check yourself if you want to. I have calcium, I have chlorine, I have hydrogen, and I have oxygen. Okay? All right. So, count. Over on the reactant side, I have no coefficient between the parentheses and the Ca. So that's just 1. On oxygen, this is in parentheses. So remember, we do that distributive property with our 2 sitting here as a subscript. So I have actually 2 oxygens. I have 2 hydrogens. Oh, but wait a minute. I don't really have just 2 because this is also a reactant. So because hydrogen shows up on both of these reactants, I'm going to add them together. So I don't want to write a 2. I have 2 over here, plus I have 1 more. So, oops. So I have a total of 3 hydrogens. And then chlorine, I just have 1. Okay, now I'm going to separate my count. Oh, wait a minute. I want to space it out a little bit because I'm going to have to do some figuring. And, okay, now let's do the count for the products. I have 1 calcium. I have 2 chlorine. 2 chlorine. Oh, go down here to chlorine. Hydrogens, I have 2. There's hydrogen. And oxygens, I have 1. So, when we look at this, our calcium, good right now. Our oxygen, not so good. So let's fix that, okay? If I have 2 oxygens here and only 1 oxygen here, how can I get 2 oxygens? Is it possible? Well, when I look at this, the only oxygen I have is sitting right here. And so I could easily make that 1 oxygen into 2 oxygens by putting the coefficient 2. That would change my oxygen, and I would then have 2 oxygens. But it would also change my hydrogen, and I can't forget that. So I'm going to have to take my 2 hydrogens and turn it into 2 H2s. 2 plus 2 is 4. Okay, so that calcium stays unaffected. It's good. Oxygen is now 2 to 2. Hydrogen, 3 to 4. Okay, and I still have to worry about chlorine. So hydrogen, I've got 3 hydrogens over here. Is there any way, when you look at the hydrogen here, when you look at the hydrogen there and the hydrogen there, is there any way to make it turn into 4? And it just so happens that, yeah, because this has got 2 hydrogens, but this only has 1, and we already know how to change 1 into 2. So I'm going to put a 2 as a coefficient right there. Okay, And that will mean I have 2 H's plus, don't forget there's a plus sign, 2 and 2, that gives me 4. Okay, so I fixed the hydrogens, but I can't forget, I gotta figure out the chlorine also because I put a coefficient in front of it, and coefficients always distribute to everything in that formula. So chlorine changes to a 2, and look at that, magic. We have 1 and 1, 2 and 2, 4 and 4, and 2 and 2. We have a balanced equation. So if this was something that you had to do and submit to me, and I said, what's your answer for the balance? You would say, I didn't put anything here, did I? So I would have 1, 2, 1, and 2. So that would be my answer for the balancing of this particular equation. Okay, 1 to 2 to 1 to 2. Is it in lowest ratio? Yes, because if it's not, then that's not going to be my final answer. But it is, so we're good to go. Okay, now, okay, got to try and hurry up here a little bit. Okay, so now I have C2H6 yields C2H4 plus H2. Okay, so I'm going to do my count. I have carbon and I have hydrogen. Carbon and hydrogen. That's it, just 2 different elements. Okay, so my initial count here, I have 2 and 6. And then I have 2. And hydrogen actually appears in 2 places, so I got to add them together. I have 4 plus 2 more, and there's a total of 6. Whoa! Okay, this is the example of an equation that's already balanced when you just have one of each of the different molecules. Okay, so how would I write that in my answer? I want you just to write the word balanced, and that would be your answer if it doesn't need any coefficients at all and the presumed ones are sufficient. Okay, all right, so there's that one. And please, if you're wanting to write this stuff down in your comp book or something, you don't have to, but if you're wanting to, I know probably several of you will, just start and stop the video, okay? All right, let's do one more. So I have, I'm not leaving room. I have C2H2. I have O2. I have CO2 plus, again, I got water. Okay, now let's do our count. So I have a carbon, I have hydrogen, and I have oxygen. There are only 3 elements involved in this one. Okay, so count initially, I have 2. I have 2, and I have 2. All right, so leave a little space because I might want to do a little changing. And my count over here, I have 1, and 2, and 2. Oh, my goodness. Watch what you're doing. I should watch what I'm doing. Okay, so C and the O here is down at the bottom. Now I have 2 O's, but I also have a third one over here, so I need to put a total of 3. And then my hydrogen, which is the middle one, I have 2. Okay, so it looks like my hydrogen is balanced, but the other 2 are not, so we need to fix them, and in turn we may change hydrogen, but that's okay. It'll work out. So, okay, I'm going to take my carbon. I have 2 here, and I want 2, so I'm going to put a coefficient of 2 here. And that'll change the carbon, but it'll also say, hey, I need 2 of the O2s, so that's a total of 4. So the oxygen is going to go to a 4 here, plus I've got this one that's still out of 1, so I've got a total of 5. Okay. So that fixes the carbon, and my hydrogen is still good, but my oxygen is not. Okay. So when I look at this, I say to myself, okay, I got 2 on this side and I've got 5 on this side. What's the common number that they can both fit into? And that would be a 10. So I say, okay, well, how can I make 10 oxygens over here? Well, this one's a quick fix, because if I have O2, 2 of them, I'm just going to put a coefficient of 5. 5 O2s, totals 10. Okay. Now, here's a little trickier. You got to think about it. This is an even number. 2 oxygens, no matter what your coefficient is, it's an even amount. But this is only 1 oxygen, and that would make everything, when I add 1 to whatever this is, an odd number. Well, 10 is not an odd number. So what I want to do is try to fix that and make it not odd. Okay, and so I'm going to double it. And that's an easy way to make this become an even amount of oxygens to add. So if I do that, then that'll make this oxygen 2 of them. What I have here is 4, so that's only 6. But let's go ahead and change that. Oxygen goes to a 6. And then because I changed the coefficient, I have to take my H's, 2 and 2. That gives me a total of 4. All right. Now, I still need to get 10 oxygens. So if I have 2 here, how many would I need to add to it to get 10? 8. Can I make O2 into 8? Sure I can. I'm going to put 4. That'll be 4 carbons. And 2 times 4, there's 8, plus, don't forget, I have 2 oxygens, and that would give me a total of 10. Okay, so now I've got my oxygens in balance, but I've thrown these 2 out of whack. Is there a way I can fix these 2? I've got 4 on this side and only 2 of each on this side. They're both sitting here in the same formula. So if I double them, voila. Okay, 4 and 4, 4 and 4, and 10 and 10. So my answer would be 2 to 5 to 4 to 2. There's my answer, 2 to 5 to 4 to 2. Okay, all right. I think that's it, and I'm about to hit the half-hour mark, so I'm just about perfect here because I didn't want to go more than 30 minutes at the most, and we're going to do that. So just a real quick, right here, some things to remember. Number 1, let me get it right, tally atoms on both sides first. 2, use coefficients to change the amount of atoms. Change the tally as you go. And you may have to change the coefficients more than once, especially on this last example. And the very last step is to make sure that ratio of the coefficients is in the lowest ratio. And that will be a final answer if it is. All right, so look for a few practice problems, some equations to get balanced tomorrow with this lesson, and submit those, and I'll put the due date and everything on there. So hopefully this will help you, and you do have it to run back through again and again. So I miss you guys. I really hope that helps. Please send me questions if you need to, and I'll try to set you straight if I need to. But you guys are some smart cookies. I think you're going to do okay. Bye.